This is the Hopper Popper Lab. You should have this in Notability, ready to go. What you're going to do is you're going to take little elastic discs that go in front. It's a little popper. If you fold it inside out and set it on the table, it will eventually want to right itself. You know, it's going to want to fold back the right way, and it will pop off the table. So practice with that right away, having it pop. Make sure you've got one that isn't ripped or broken. That's actually gonna pop off the table. You should have a meter stick as well, so make sure you get a meter stick. And you have the popper ready to go. And you're gonna need to measure how high off the tabletop that the popper goes. So do it a bunch of times. It's fun, and just try to get a height in meters. You want to make sure that you're converting from centimeters to meters in this table. So do it a bunch of times, get 3 that are good, and then go ahead and take your average for that. We want to have a mass of the popper, but since we don't have a scale in the room today that I'm aware of, I'm going to go ahead and give you that mass. So the mass is 20 grams, which you need to convert to kilograms, and I'm going to let you do that. So make sure you convert that into kilograms, the 20-gram mass. I'm going to help you with part 3. So on the next slide here, I'm going to show you how to draw a flow chart of the energy transformation that this Hopper Popper goes through. So if you're starting at the bottom, you've got your popper, and it is sitting inside out on the table. And when it's sitting inside out on the table, what it has is all elastic potential energy. So the reason it has potential energy is because of the material that the Hopper Popper is made out of, and we call that elastic potential energy. And it's going to spring, it's going to pull itself the right way, and that's where it's getting its energy from. Then once it pops, which is the fun part, it will sort of flatten itself out, be deformed for a moment. Here's your tabletop, kind of going through time here. And then it is going to continue to fly in the air as it's moving. And when it does that, we have kinetic energy at the bottom, and then as it moves, it is converting to potential energy at the top as it pops off the table. And so I want you to talk about with your lab group, thinking back to roller coasters. So if you want to go back to all that work we did on roller coasters, think back to what happens to the potential and the kinetic energy as you get higher and higher off the ground. And with that information, you should be able to answer the question, where is the energy 0? So energy is 0. Where? Once you know that, you should be able to fill in many parts of the data table. So after you have this discussion with your lab group, I would go ahead and take a look at this data table here. And if you read closely, it says that there are some easy spots to fill in information on this data table. That should be enough to get you started on this lab. You should be working in your brand new lab groups, and I will see you soon.